So the numbers can be presented as a fraction form, as you may know, or they can be, when I divide 1/2, I can write 0.5. So decimal numbers have a integer part, the period, and some decimal part. This is the decimal part, right? The decimal numbers are composed of integers, period, and whatever. Now, some decimal numbers, like for example, the square root of 3, if you remember, we talked about that. The square root of 3 is an irrational number. It goes on forever with no pattern whatsoever. So it's 1.7320 and so on and so forth, 5, etc., etc. But for example, 15 divided by 2, this is a decimal number with a terminating decimal. It's clear. 15 divided by 2 is 7.5. What about 1 divided by 3? How does this look like? This is a repeating decimal. So this is an irrational number. We discussed this when we discussed numbers. This is a decimal number with a terminating decimal. 1/3 is 0.33. This is called a repeating decimal. Because it repeats forever, we like to put a bar on top of it. That's the repeating decimal. This can never be changed into a fraction without approximating the number. It's not going to happen. This is already a fraction. It's a terminating decimal. Even this one, which is a repeating decimal, can be changed into a fraction with no approximation. But this one cannot. Okay. So back to the book. Of course, when we add and subtract, this is what I would like. So list the digit that has the given place value for the number below. So the digit in the ones place is the first digit after the period. So the digit in the ones place is 8. The digit in the so-called 10th place is the 0. They're not talking about 149. So THS. Okay, the digit in the 10th place is the 4. The 4 is in the 10th place. But when you see 10th with a THS, it talks about, so the digit in the ones place, sorry, I messed up here. The digit in the ones place is 9. That's the digit in the ones place, 9. The digit in the 10th with a THS is the 8. And the digit in the 10th with a TENS is the 4. So when you see 10th, THS is the first digit after the decimal number. When you see 100th with a THS, they refer to 0. When they say the 1000th with a THS, they refer to the 5, the digit. Any questions on this?
Could you repeat what the 5 would be?
Yes, it's the 1000th. 1000 with THS.
10th, 100th, thousands.
Correct. Identify the digit that has the given place value in the following number. The 1000th. So this is the correct spelling. So now we want to find the 4th digit. So the 10th, the 100th, sorry, the 3rd digit. 10th, 100th, 1000th. So this 9. 9 is the 1000th digit. 9. Write a decimal as a fraction or a mixed number. Very good. So 0.1 is 1 divided by 10. Why 10 and not something else? Because you just simply count the number of digits after the decimal point, and that you will put as many zeros as needed. So if I have 0.934, it's 934 over 1 followed by 1, 2, 3 zeros. If I have 0.0022, then it's going to be 22 over 1, 2, 3, 4 zeros. Good. Okay, to convert 0.85 to a fraction in lowest terms. So 0.85 is 85 over 1 and 2 zeros because there are 2 digits after the period. I know both numbers end in 0, so they are divisible by 5. So 8 divided by 5 is 1, and in 45 is 9. You cannot simplify any further. This is it. That's how we convert from a decimal number to a fraction. Okay, the same thing, and simplify. Round the number to the nearest tenth. Tenth is the first digit after the decimal. If the next number is 5 or more, so they want us to round to this digit. If the next number is 4, 5, 6, no, I meant 5, 6. From 5, 6, 7, 8, or 9, I will change the number into 0.3. If this digit is 0, 1, 2, 3, or 4, I cannot change or upgrade if you want to a 2 or 3, so the approximation will stay as 0.2. If I have 0.245 and I am asked to round to the nearest hundredth, I look at the next digit. The next digit is 5 or more, so then this will be approximated as 0.25. Are we okay with this? Okay. See if there is anything else. Round this number to the nearest hundredth. So 399. So careful with this. Negative 18.399. They want us to round to the nearest hundredth THS, right? Because this is a number here, I have to round up from 9, the next one is 0. If this one becomes 0, of course this one becomes 4. So then the approximation is negative 18.40. There is no need to write the last 0 or as many zeros as you want. There is no need after the last decimal piece, decimal digit. If it's 0, you don't have to write it. If it's anything else, you have to.
Why did the 3 change into a 4?
Very good. Let's do that again. They are asking us to round to the nearest hundredth. Because the next digit is 5, 6, 7, 8, or 9, I have to increase the 39 by 1 digit, by 1. 39 increased by 1 is 40. There is no need to write the rest of the zeros after the last decimal digit. Okay? When we round to the nearest cent, that means the second digit, the 100th digit, because the next one is a 9, then we have to write 0.64. $128, 0.64. Run to the next 100, the same thing. Okay, so here they want us to identify which one is larger. So let's work on this problem. Negative 2.44 and negative 2.42. It's a very good example. Okay, so the question is this the correct symbol, inequality
No.
symbol, or is this the inequality symbol? So here's how we compare. First of all, you have to be careful because these are negative numbers. So when you look on the real line or the number line, they are both at negative 2. So this is the negative 2. But now, is 44 or 42 further to the left? So 44 is further to the left than 42. So then this is a larger number than this. You only need to compare the negative side of negative 44 and negative 42. Because negative 44 is to the left of negative 42, this is a larger number than this. Is this okay? Is this okay? Yes, no. Okay, so let's talk about adding and subtracting decimal numbers or a mixture. So we have negative 7.874 plus negative 25. We always take care of the signs first, right? I have the positive times a negative. So this is negative 7.874 minus 25. This is an easy situation. Yes, I allow calculators, but it's important to understand this. Because both numbers are negative, I'm going to add them. Copy the sign first. And how do I add them? Please remember you have to write them one below the other, and you have to line up the decimal point. So 25, you can put as many zeros as you want afterwards. It's not going to change the number. But 7 point, so you have to line up the decimal point. 874. That's why I continued with some zeros. And when you add this, of course, 4 and 7 and 8. 7 plus 5 is 12. And you carry a 1, so this is 3. Please remember the decimal point had to be lined up in order for you to add these numbers correctly. So that's why we have 32.874. Good. Let's see what else. Same thing. Let me know if you want to work on any of these problems. We have 3 numbers to add or subtract. Add and subtract.
Can we work on that one?
On 20?
Yeah.
Perfect, yes. Good. So we have 5.8 plus 4, and then minus 7.3 minus 9. Perfect. Good. Good. So the first piece is clear. I have 5.8 adding 4.0. You have to line up the decimal digit. Nice, 9.8. Careful now. 7.3 minus 9, which one is more powerful? That one will dictate the sign inside. What is the sign inside?
Negative.
Yes. Now, I have to subtract from 9.0. Why 0.0? Because there is only one decimal digit here. I have to subtract 7.3. Remember, they have to line up. When we add and subtract, not when we multiply. So careful. When we add and subtract decimal numbers, they have to line up. The decimal point has to line up. So, but now remember we are subtracting. 3 from 10 is 7. I borrow the 1. 7 from 8 is 1. So this is the answer. At this point, the opposite of a negative number, I have to change this into positive. Now this is nice. I add them, 9.8, 1.7. Remember that the decimal point has to line up. 8 plus 7, 5, and I carry a 1, so 10 plus 1 is 11. Please remember the decimal point has to line up. So the answer is 11.5. Any questions on this? Any questions? Okay. The same thing, we're just evaluating, plugging in, the same thing. Simplify, yes. Let's work on this one. So this is a minus 0.11a equals. Please work on all these problems and come back on Thursday and say, I need help on this, I want to see this, I want to see that. Okay, so there is an imaginary 1 in front of a. The same thing with x. There is an imaginary x, a 1 in front of x, and so on and so forth. There is a 1 in here. So what we're really doing is 1 apple minus 0.11 of an apple. So 1 point, I need 2 zeros. Why 2 zeros? Because the other number has 2 digits, from which I have to subtract 0.11. Remember the decimal points have to line up. 1 from 0 is a 9. But remember, I borrowed and I have a 9 here now. So 1 from 9 is an 8. And then I have 0.089. So 0.89. I didn't ask, but 1 is bigger than negative 0.11, so of course the outcome is positive. Any questions? Any questions? Of course, A, of course. Thank you. Good. Let's continue. Okay, simplify the expression by combining like terms. Let me know if you want to work on something like this. And solve the equation. So, I think we have time for solving an equation and simplifying like terms.
We did 29.
Yes, very good. Let's work on 29. In 29 we have 6.3x plus 4.5 minus 3x minus 8.7. Perfect. And then we're going to choose an equation. Okay. Remember, these are the terms with x, and we always start with x because we need a degree and so on and so forth. But this is easy. From 6.3, I have $6.30, and I subtract $3. So this is easy, 3.3x. But now let's look at these two numbers. The most powerful one is negative, so then I would have to subtract. When I subtract them, I have 8.7 and I subtract 4.5. The decimal points have to line up. 5 from 7 is a 2, and 4 from 8 is a 4. And this is it. Remember, degree is, leading term is, and leading coefficient is. Can anyone give us the degree of this polynomial or expression?
1.
Yes, very good. It's an imaginary 1 in here. That's the only power we don't write. And what is the leading term?
.3.
3.3x. What is the leading coefficient? 3.3. Good. Let's also look at an equation. This one or this one. Okay, let's work on this. Negative 15.99 equals x plus 7.14. Okay, so this is a term. It does not belong together with x. It has to go to the other side. The sign will change from positive to negative. So then x equals negative 15.99 minus 7.14. Please establish the sign first. This is a debt and this is another debt. I have to add them. So I have 15.99, 7.14. Remember, the decimal digits have to line up. 9 plus 4 is 13, 3 and 1. This is 10, plus 1 is 11. I carry a 1. So I have 5 plus 7 is 12, plus 1 is 13. And I have another carry, another 1, so this is 23.13. Any questions? Any questions?
We have time for one more like that?
I'm sorry?
We have time for one more like that?
Yes, we do. So what I was going to ask to show you is that what is left for hopefully just the first half of Thursday is how to multiply and divide decimals and how to do more algebra with them. And that's the end of the material for test 1. So good. So we want to look at another problem like this. Here they are just asking to plug it in to see if it's a solution. Okay, so here's another one. So negative 19.99 equals x plus 4.28. So in the same way, this does not belong here. So then x equals negative 19.99 minus 4.28. Because both numbers are negative, because both numbers are negative, I have to add them. It's a debt if you want. So the number, that always establish the sign first, and then you know that you will have to add 19.99 and 4.28. Have to line up the decimal digit. 17, 7 and you carry 1, so that's 10, 12, and you carry 1 again, 10, 4, 14, you carry 1, and it's 2. Copy the decimal point, one under the other. So the answer is negative 24.27. So between now and Thursday, we have a lot of work. So what is left for us is just 2.7 and 2.8. Okay? And you have everything including 2.6. Learn and practice. And we only have 2.7 and 2.8. How to multiply decimal numbers and how to solve more equations with decimal numbers. And that is the end of the material. The rest of the time I want to review for the test.
Wait, Professor.
Yes?
So what should we all have done by Thursday?
Everything including 2.6. The only remaining ones for next Tuesday will be 2.7 and 2.8.
Okay, understood. Thank you.
Yes.